And welcome back to another episode of Containers on the Couch. I'm your host, Meish. I'll introduce myself later, but I first want to introduce my wonderful guests, Zahi, Jim, and Anthony. Zahi, please tell us who you are, what you do in AWS.
Thank you, Meish. Hello, everyone. I'm a senior prototype architect in the GFS, Global Financial Services at AWS. And we build something called OPA on AWS, which we're going to present today.
Anthony?
Hi there, my name is Anthony Watson. I'm also a prototype architect at AWS, and I'm one of the contributors to the project that we're going to demonstrate today.
Jim?
And like Anthony and Zahi, I am also a member of the team that's been working on prototypes and contributing to the OPA on AWS solution. And my name is Jim McVea. Nice to meet you all.
Thank you very much. And my name is Meish Seidel-Casing. I'm a developer advocate with the ECS service team. And I already see we had our first person to say hello. So thank you, Shreyas, for saying hello in the chat. Everybody else who's on the chat at the moment, please feel free to give us a wave, say hi, let us know where you're joining from. Post your questions while we're over here. We would like to get your contributions and your interaction. The questions help us also drive the conversation. So you also use prototyping architects. Is there a specific team that does that? Well, how does it, I assume you all work together. So how does it actually work?
We're essentially part of the FSI GFS prototyping team for North America. We focus mostly on global financial customers. That's the majority of customers we help. And we deal with different problems. About a year and a half ago, we landed this problem and we decided to build something. And little did we know at that time, the momentum and some of the feedback we got from other customers. And here we are today, coming to share with more customers about what we built.
Okay. So I assume everybody here on the call today is interested in answering the question we're talking. We're talking about OPA. OPA, for example, I've got a comment on Twitter earlier before. It says the OPA in German or in Dutch is a grandfather. So I'm assuming we're not talking about somebody's grandfather here today. So what is OPA? What does it stand for? What does it do?
OPA stands for Orchestrate Platforms and Applications. It's a name we gave to a reference implementation for a developer platform that is based on Backstage.io. And the intention of this is to build a platform that makes it easier to use AWS services with the focus of containers, but not only containers.
Okay.
The idea of OPA is essentially, if we started this with customers that asking us, well, how could we use services like ECS or EKS in an easier manner? Because now our teams have to learn and they have to know how to use those services. And we figure this is not only a problem of orchestration, but it's also an operational problem that needs to be managed. And when you think about enterprise customers, this problem is very hard. There's a lot of restrictions and guardrail and security. So we decided to build this reference implementation to help customer build this.
And why did we build this? I mean, for example, was it because of a certain customer that asked, or because we know that it's AWS, we are customer obsessed, and 90% of the things we build today are because of customer requests or reach outs or their needs. So how did this come about?
Yeah, I'll take that one. So as we did with our introduction, and as Zahi was explaining, we're a group of prototypers, and so initially we did get a request from a customer that we were working with that laid out several different requirements for us. They were looking to get off of an on-prem cloud environment. They wanted to migrate to AWS. So they were looking for patterns and paths that they could use to migrate their applications to AWS. Their group of hundreds or thousands of developers were used to this on-prem solution. They didn't necessarily have the AWS skills yet for understanding and knowing how to use VPCs and networking and security and IAM. So one of the requirements that this customer gave us is we really need a simple developer experience. We need to make sure that these developers have as few barriers as possible for getting their code deployed. I guess in a nutshell, allow those developers to focus on what they do best and writing code. Another requirement from them was a lot of their applications, when they did some analysis, they were, I can't remember, I think it's like 80% or so were container applications, or applications they wanted to containerize and run on AWS. So those are some of the high level requirements from this particular customer that we were working with. So we kind of looked around at the landscape of solutions that might be out there, things that we could build on top of. And we ran across Backstage. This was almost a year and a half ago or so. And at that time, it was fairly recently promoted into an incubating project with on CNCF. So it had some promise. It was gaining some traction and gaining some legs to run. And so we started experimenting with that. We looked at what it was capable of, and with that plugin architecture, we thought this is a really good platform for us to start looking at how can we integrate that developer portal platform with AWS. So we set about building, starting on a prototype for this particular customer to build out plugins that provided the integration with AWS, provided that simple experience for developers. Vision a lot of the infrastructure that the application developers didn't really want to have to deal with. So that's kind of where we started. We did start hearing a whole lot of similar requests from other customers as we started building out this solution. We just started to recognize a much broader interest. And so we found ourselves kind of embarking on open sourcing the solution after we finished that initial prototype. So that's a little bit about kind of how we got started. It really has been a long process to build something with the level of scope that we did for this particular prototype. It was a little bit larger than what we typically do with prototypes. And so because of those similar requests from other customers, we had internal discussions about what can we do to scale this solution to help those customers with similar needs. So we started working on open sourcing it. I think we got a lot that we could probably say about that. Anthony, do you want to talk maybe about some of those next steps that we took? Why we open sourced the project, some of the challenges we faced. There's a lot of context back there on that.
So before Anthony jumps in, I have one question, because you
Sure.
mentioned something which I'm not sure everybody. You mentioned something called Backstage. What is Backstage?
Oh, sorry about that. Yeah, so I mentioned Backstage and CNCF. So the Cloud Native Computing Foundation sponsors a whole lot of projects that help support cloud native. This is where you see Kubernetes and Crossplane and Argo CD. Backstage is a project that focuses on providing an improved developer experience. It provides a developer portal that allows application developers a single pane of glass with an interface to be able to get started with building new applications, and aggregating a lot of the tool set that they need to deal with on a day-to-day, week-to-week basis into that single pane of glass. So it's very much focused on improving the developer experience in building and managing applications, specifically in the cloud.
And Anthony, the question was, for example, why was it all because of the developers? How did we actually build this, open source it? What was the process?
Well, every company has a unique set of tools that they prefer to use in their tech stack. And so it becomes a challenge to provide a single out-of-the-box solution that happens to have all the same tools all integrated in a perfect way. So that can also be a challenge, because a lot of companies, they want to say, well, can we just have a platform as a service? And can I just buy a platform and that's going to kind of solve all my problems for developers, and they'll get some nice portal and it'll be super easy. But in addition to the expense of some of the solutions that are out there, you have a flexibility problem. What happens when you want to customize the UI to show a particular view that's specific to your business or use case, or you're using a tool set that doesn't already have a pre-integrated solution for that particular vendor. So what we did is we thought, okay, what's the most flexible approach that we can possibly take? And so we found Backstage, which is open source. And we were able to build upon it with a plugin approach so that we could do integrations with AWS. And what we were trying to do was solve the problem for developers to give them a single pane of glass that simplifies their experience, as well as to help out with the cloud engineers that typically put together reusable templates and infrastructure as code and whatnot. So what we wanted to do was just enable full flexibility to integrate the developer portal with whatever technologies customers wanted to use, whether they use infrastructure as code like Terraform or CDK or Pulumi. We wanted the customer to be able to choose. Same thing with like Git solutions and their CI/CD solutions. We wanted to be able to show, okay, your portal is now integrated with your CI/CD pipeline, so you have a view of what's going on. But you can use whatever CI/CD solution that you want. So by going with this open source approach where everything is free and everything can be customized, there's really no limit to what the customer can do. So what we like to say is that our solution is free as in puppies. So if someone gives you a puppy, obviously, they might not charge you for the puppy, but you've got to do the cleaning and the feeding and everything like that.
And it's with you for quite a while. Yeah.
Yeah. Platforms are not free. It's an ongoing, evolving thing that is specific to a particular company and their situation and their choices. So you can't really get away from that. But having the full flexibility to own the solution and make it exactly what you want is very powerful.
In addition to this, it's not just giving you that integration. That integration was built on best practices that we have built based on our global financial customers. So a lot of things like security and compliance are embedded in the way the examples we share. So we find it very common for many customers to ask the same things. So, okay, we build workloads with individual accounts. We separate environments and workload based on different clusters. So whatever that, what we call foundations or separation of foundations versus the application that are getting deployed, we kind of build a model that is based on what we have learned across different customers and different teams we have observed.
I would actually, one second, if you don't mind, gentlemen, before I want to say hello to somebody on the chat who actually dialed in as well, also from Israel. I want to say hi to Dov, and I want to thank Dov for introducing me to the three of you. So we actually got to the show, and it's mostly because of Dov. So thank you very, very much for making the introduction, and thank you for joining us today.
Great. I think we want to talk a little bit. We have a demo, right? And we're going to show some actual, how does it look like? We can talk a lot, but without seeing, I think it's going to be limited. But before we go to the demo, we kind of want to show a little bit of the architecture of what OPA built on. And in addition, we'll show, okay, if somebody wants to use it, what does that mean? I'm going to share my screen quickly. Can you see my screen? All right. Can you see my screen? Okay.
Very good.
So what this screen actually shows is a common practice of our initial release, or essentially what's on GitHub. But it's also the model for us when we start working with different customers. At the moment, we just finished another customer customizations where they were saying, look, we don't use GitLab, we use GitHub. And we don't use code commit, we use harness for their pipelines, code deploy. So we happen to start adjusting those tools into the platform so they can have their own unique platform with their existing tools. So one thing you need to remember, you don't need to deprecate your tools. On the contrary, you need to adapt your tools into a platform so you're going to get the benefit of what OPA gives you, which you'll see in the demo in a second. And just to set terminology for those of you who are not unfamiliar, the concept of platform engineers and application developers, and what are these entities? So application developers is the classical logical application to build usually things like Java applications or put the business logic into practice. And platform engineers are people who are responsible on building those guardrails and golden path so that the rest of the developer can be focused on their building their logic. and not having to deal with things like security guardrails or standards or other things the organization needs to enforce. So this is kind of the model we've been following to change according to the tech stack and the required technologies so that we can deliver this into the rest of the developers and let them use AWS. Oh, how does the... yeah.
Sorry, I have one question, if we can, because this kind of sounds like we're reiterating on the DevOps kind of methodology. I mean, the fact of developers doing only their code, ops people only doing their ops, and now we have application developers and platform engineers. They're kind of the same thing or completely different?
Well, it depends which organization you ask. Some organizations look at them and say, my developers, they not only build the application, they build their specific golden path, and they own everything from designing their templates and path all the way to actually building an application on top of it. That has advantages, but disadvantages as well. But some customers in our financial world, I would say the majority of them separate the two. So they say platform engineer entitled or responsible to building the platform and responsible to building the golden path and the foundations, things like networking, things like security, and also how, for example, if you're talking about ECS, how does an ECS cluster supposed to look like in our company? So they are the one who make those decisions. And an application developer relies on those foundations to actually execute and build application on top of it.
Zahi, if I could add to that, I would say that one of the distinctions that we have between the platform engineers and the application developers is that a lot of companies don't necessarily want all of their application developers to have to go to cloud school and know all the details of how to implement a cloud and deal with things like deployments and scalability and whatnot. So typically companies will bring in a somewhat small number of cloud engineers or cloud experts. Sometimes they'll call them solutions architects or platform engineers. And those people are designed to take on the task of really being cloud experts and designing those scalable solutions and working with the developers. And I think another difference between that kind of a DevOps and what we're talking about here with our developer portal is a developer portal enables the platform engineers to provide a self-service and intuitive user interface for developers to interact with. So it's not just developers cut a ticket to some DevOps person and they handle something. Instead, it's developers have a portal to go into. They can spin up their own types of infrastructure based upon the golden paths that have been already set up.
Thank you, Anthony. And that's also one of the major issue. We talked about how this was born. The platform engineers is very scarce resource. It's very hard to find people who knows cloud all around, but also what the actual application developer needs. So that combination is hard, and therefore they're usually the bottleneck in an organization. So bringing this idea of a platform is allowing you to accelerate the rest of the developers who will take more time to upskill on cloud skills.
Yeah, makes a lot of sense. And from my experience, it's exactly the case, specifically in big organizations that I've worked with.
Yeah. So what's actually OPA? If we try to start small, just ignore all the right side of the screen, because that's what's basically got generated from the platform. But on the left side of the screen is where we can see our actual platform, is our Backstage. OPA resides on top of Backstage. So you still need a vanilla Backstage to run. You can install those plugins on top of it. And just out of the box of Backstage, you can integrate any kind of identity provider, things like Active Directory or Okta. And they are very easily interchangeable in case you want to use different one or your organization use a different identity provider. Apologize. Sorry. On the bottom, we have our source control, or our source of truth as well. We use GitLab, but we recently start writing implementation for GitHub. We'll hopefully release that soon. So whether you're using GitLab or GitHub or Bitbucket, essentially you can use any kind of source control. But more interestingly, you can see there are different repositories that we hold the actual templates we're going to use, the pipelines, the apps themselves, the concept called environment, which we'll talk about in a second, and resource and providers, and also migration plans, because you can use all of this to migrate a lot of containers. But what does actually the platform do? Right. So I have a platform engineers who design those pipelines and environments and templates. They basically orchestrate how things should be created on the cloud. And essentially, the platform or the developer can interact with it and start creating applications. Now, what you can see here on the right is essentially different types of patterns that could be built. They are distributed across different accounts, right? We use Terraform and CDK to provision them, so you can choose whichever you're more familiar or more comfortable with. And in each one of these different patterns of account, you can see we have different setup. So here we have, for example, Kubernetes. And here we have ECS cluster or clusters. And here we have serverless. We even recently released a Gen AI. So if you want to build a Gen AI application, there is a particular set of resources that will help you to build containers much faster for Gen AI applications. And a very other common practice we've seen is those accounts that get provision can very easily integrate with Control Tower, AWS Control Tower, and AFT, Account Factory for Terraform. If you're not familiar with these are services that AWS offers to manage and control your accounts that are provisioned. Also put your security guardrails and SCPs and many other things. When you're dealing with enterprise, you usually will have something like this. So the point here is to show the accounts and environment and application that get deployed by the platform are still controlled by your account provisioning process, whether it's Control Tower or something else. There's some more technicality which we're not going to cover just because we don't have as much time as we wish about the different roles and how does that help us to give access to a particular environment. And also for the pipeline authorization process, so we can control what goes and actually perform and by whom. There's basically two identity, the platform identity and the pipeline or the provisioning pipeline identity that are used to assume credentials to different accounts and different regions. Just before the demo, I want to cover one more thing to show. So as we talked, our application for our developers are focused on creating apps. But it's not only apps, it's also shared resources, which we'll see how it could be useful to create a resource that is being used by multiple applications, multiple components. But these components, before they can be created, or these resources, they need a place to exist. That place we essentially call environment. But environment in OPA is just an abstraction. There is actually not anything existential in an environment. It's just an abstraction that captures where these things are deployed. And an environment has an association with the environment provider, which we implemented AWS environment provider, which could be extended to other providers. And the patterns we have implemented for these are things like ECS environment provider and Kubernetes environment provider and serverless and API gateway, essentially pattern provider, and a Gen AI provider that allow you to build particular Gen AI applications. So what are these providers? The providers essentially are the foundation, so you can deploy those apps and resources on top of it. A very common aspect of resource of providers are things like VPC networking, security, permission sets, and roles that gives you access to that particular type of workload you're trying to build. I'll give a pause to see if there's any questions. It was a little bit dense.
So there was one question which came up, and the question is, I asked you this before earlier in the week, the fact of the OPA, or is usually known as something else in the open source world.
Yep.
And one of our viewers by the name of Electric Universe of OPA for the first time, something with open policy access or open policy administration. So we're not talking about that because that's something very specific, which is another CNCF project. I understand this is not a CNCF project. It's built upon Backstage, which is, but
Correct.
This is a completely different product.
Correct. Maybe in a funny way, you can actually integrate Open Policy Agent into this. I'll have to answer later. And we may actually change the name soon because of that confusion. But this is not Open Policy Agent, just to clarify. You can integrate Open Policy Agent on top of how we provision resources, right? Essentially, this is all infrastructure as code. So you can use something like Open Policy Agent to decide whether you approve or decline a specific request of infrastructure as code to be provisioned. But that's a different topic. It's called Policy of Code. If those of you are interested, you can look it up. So platform engineers that we mentioned before, they are responsible to creating those environments and providers, so the rest of the developers can be more comfortable just deploying their apps without figuring out the complexity and the details of the backend side. We'll jump to the demo just before. If you're interested to look it up and see what do you get out of the box, essentially getting the complete source code of OPA and the set of plugins, 4 or 5 plugins. You get, I think, more than 15 different types of templates. It's a mixture of different development languages such as Node, Java, Spring Boot, Python, and you can kind of mix and match between them and the specific runtimes we have built, such as Kubernetes or ECS. So you can decide, I want to run my Python on a Kubernetes or a Python on ECS. And we also have shared resources example, which is S3 and database, which is the most common shared resource we have seen. And of course, security best practices, the patterns that OPA gives you are patterns that were born from financial organizations. So they are things we have built along with customers in that industry. I'll end with that, and I'll give back the opportunity to Jim to give us the demo.
Okay.
And while Jim's bringing up his screen, I just want to take an opportunity to welcome all the people that are perhaps catching us somewhere in the middle of the recording or have just joined the show now. We are here with Zahi, Jim, and Anthony talking about OPA on AWS. If you missed the first half an hour, scroll back and watch it. It's very, very interesting. And if you have any questions, of course, please drop them here in the chat. We're happy to answer them. Over to you, Jim.
Okay, perfect. Thanks. So, so Zahi gave us a little bit of background on kind of the architecture, showing the different roles that are typically involved in using OPA. And so I'm actually gonna walk through a couple of things with those different roles, or different hats on. I'm going to start with saying, okay, I am a platform engineer. And a member of that team. And one of the things I want to do is create a new containerized an environment to run containerized applications. And I want to specifically create a new ECS cluster. So what I'm showing here is the Backstage UI. Now this is, as Zahi explained, our reference implementation that has the OPA plugins that we've developed deployed into a Backstage instance. We have built out the IAM roles, and a lot of that is part of the infrastructure provisioning that's part of our reference implementation. But so there's a little bit of background installation and configuration that's been done, and what we end up with is what we see here on the glass. And so what I'm going to start with, again, as my platform engineer hat on, is say I want to create a new environment. This is the creation interface for software templates. What we see here is that deployed into this particular OPA instance are several different software templates related to creating environment providers. And as Zahi was explaining, those environment providers give you the concrete implementation of all of the AWS resources required to provide a complete runtime environment for applications. We can see here that we've got a template that can be used to kind of stamp out a new ECS environment that uses EC2. I've got an ECS Fargate environment provider to allow me to quickly create an ECS cluster using Fargate. And then there's more. We've got additional templates that provide examples on creating EKS environments, Gen AI environments, serverless. But for today, kind of keeping with our containers from the couch theme, we're going to take a quick look at starting with a new ECS Fargate environment provider. So let's say containers from the couch is going to be the name of the environment. Typically, this would be something where you might have an HR department that needs a new environment for their payroll app that they're developing. So you might call it, HR ECS environment or something like that. But you name it something that would be meaningful to you. You might give it a prefix just for simplicity in terms of identifying some of the AWS resources that are going to be created, my description. So you can provide basically the minimal information required to set up an environment. I'm going to be an owner as a member of a DevOps group. Now, these groups are coming from, in this case, Okta, where we have groups that have been pulled into Backstage, and DevOps team members are typically going to be the owners of an environment. Here, I might give my account number for where I want this ECS cluster to run. And then also, I'm going to specify a region. So I'll leave this as US East 1. The environment role, ARN, is going to be an IAM role that is going to be used for provisioning any new resources into that environment. So the ARN role that you specify here is going to need to have the proper policy permissions that allow for things like creating task definitions, creating ECS services, some of those things that the AWS resources that are going to be required to build and deploy and run an application, to provision an application into this ECS environment. We have options to be able to, for those DevOps engineers or the platform engineers that are building this, to create new VPCs or use existing. The key thing to kind of call out with this is this entire interface is completely customizable, and a customer can tweak this and modify it to meet their needs. So if they only ever want to use existing VPCs, then you might not have a drop-down option for creating new VPCs. I'm not going to walk through the entire wizard. There's really not too many more pages other than specifying a Git repository that you want to create. What's going to happen with finishing out this wizard is that a new Git repository gets created, and that's going to be the home for the infrastructure as code that is going to provision all of the resources for this ECS cluster. That's going to include the networking, some SSM parameters. It might include some secrets that might get created in Secrets Manager, as well as that ECS cluster itself. But all of that's going to be taken care of for you as part of running through scaffolder actions that are behind this template. So a series of actions that take care of creating that repository, populating it, and then creating the GitLab pipeline, that CI/CD pipeline that's going to actually execute and do the provisioning of that infrastructure as code. Let's take a look at what the result of that would be. So here, I'm going to, in the interface, click on this AWS pop-out menu. I'm going to go to Providers, and this AML EMEA Dev environment provider is going to show me the details of an ECS cluster that has been created in the past. So what we can see here, a lot of this is out-of-the-box capability from Backstage. We can see dependencies between the environment provider, who the owner is, application that might be, an environment that might be using this environment provider, an application that's deployed to it. And then we can also see some of the AWS infrastructure references, these paths here, like an audit table with a /AML, AML EMEA Dev. These reference paths in Systems Manager parameter store that contain the ARN for a DynamoDB audit table, or contains the VPC identifier for the VPC where this where ECS services are going to run deployed to this cluster. If I switch over the CI/CD tab, this is going to be, as part of the customization of this reference implementation, provides us with insight into the GitLab pipelines that exist for this particular environment provider. We can see the executions of those pipelines that have occurred. And then we've got a management tab for doing your CRUD type operations against this environment provider if we were finished with it and we wanted to delete it. I'm going to come back to viewing the source in just a minute, because I want to finish out kind of from the UI what else might happen next. So as a platform engineer, I've created this concrete environment provider that encapsulates all that AWS infrastructure for my ECS cluster runtime environment. But the next thing that I want to do is I want to keep this super simple for the developers, for those application developers. I don't want them to have to know much of anything about the environment that they need to deploy to, other than a single name. And in order to do that, we've got this abstract concept called an AWS environment. And similar to what we just walked through for the environment provider, there's also a wizard that will allow you to create this abstract layer. And essentially what we're creating here, if I create containers from the couch, an environment, I'm going to create a single name that the application developers can target. So when they are ready to create a new application that they want to run in this containers from the couch environment, all they have to do is know CFTC, and that's all they have to care about. They don't need to know the account number. They don't need to know the region. They don't need to know VPC identifiers or even the cluster name. All that's been abstracted away for them. And so what they end up with, if I switch over here, let's take a look at this AML EMEA dev environment. This one name is all that the application developer needs to know about. And so what we can see behind this AML EMEA dev is that it has been associated with this AML EMEA dev environment provider. And one of the things that I'll call out here is this add button. So an environment as an abstract concept allows for the platform engineering team to simplify the deployment options for application developers. And so if you wanted to support multi-account or multi-region scenarios, so that an application can be deployed to multiple accounts or multiple regions for disaster recovery use cases, that is easy to add into the environment, and developers don't need to know about it. So I'm going to switch now. Okay, let's say that as a platform engineer, I have created these environments and the underlying environment providers. Now I'm going to switch my hat and say I'm an application developer. And so what I'm going to do when I come in and log into Backstage in this OPA reference implementation is I've got different templates that I would want to access. I'm going to be responsible for creating applications that are going to run in this environment. So I might be interested in building a Node.js microservice. And so I'll choose this golden path application template that's going to, similar to what we just talked about with environment providers, it's going to give me a Git repository. It's going to give me a starter GitLab CI/CD pipeline. It's going to include the infrastructure as code that is going to create the ECS service and task definition to run and deploy my application into an ECS environment. But I don't need to necessarily know that. And we're going to take a look at the contents of the Git repository in just a second to show how we might be able to allow developers to improve their skills over time.
And by the way, customers can change any of this, from the template itself to the infrastructure as code behind it, to the pipeline or the pipeline tool they use. So whether you're using, like, even where the logs are going to be done, you can change it to go and send it to Splunk or other tool that you may be using. I think that's the true power of something like this in compared to maybe other products that are telling you exactly this is how it's going to work, but you can't change anything. Sorry.
Yeah, thanks for calling it out, Zahi.
Sure.
Okay, so just to emphasize how simple this is for application developers, if I start this Node.js microservice template, I'm going to provide a name and a description. I want this application to be owned by a developers group. And here's where the simplicity of the environment, that abstract component, comes into play. All I need to know is that I want to deploy this application to an AML EMEA dev environment. And that's it. Beyond that, I'm going to specify the name of my Git repository and within my app, and then I would review it and then click on create, and that create triggers the series of scaffolder actions that's going to create that repository. It's going to take care of building the GitLab CI/CD pipeline and automatically invoke that pipeline to start provisioning the infrastructure resources to build and deploy my new Node.js microservice application. So let's switch over and take a quick look at what the end result of running that create would be. So I'm going to come back over to my AWS pop-out menu, and I'm going to choose apps. And here I can see a catalog of all of the applications that had been created previously. So I'm going to take a look at, say, this AML EMEA detection application. I'm going to walk through some of the UI that the developer gets by and emphasize here, what they get by bringing everything together into a single pane of glass. They again get that relationship view that lets them easily see that their application has been deployed to the AML EMEA dev environment it's going to be owned by developers. If I scroll down a little bit, I've got quick access to a Git clone repository URL, so I don't even have to go into GitLab or GitHub here. I've got information that allows me to operate my application. So I think I'm going to pause here for a second and highlight a couple of things that we really focused on with the OPA solution. Backstage is fantastic for day one operations. It helps provide that golden path that gives developers a really quick way to get started with different types of application patterns that might leverage multiple languages. It might leverage multiple application patterns. It gives them those pre-built CI/CD pipelines. But working with enterprise customers, it's not just about day one activities for developers. They need some of those day two activities as well. And when we talk about what those day two activities might be, it's going to be things like I, as a developer, need to be able to troubleshoot my application. I need quick access to the logs. I need to be able to stop and start my application. I need to be able to modify the configuration of my application. And so here's a couple of examples that we built into OPA that simplify that developer experience. Here on the application state card, I can see very quickly the status of my application and that it's running right now in the ECS cluster that it's been deployed into. I can stop it and start that task very easily directly from the OPA interface without having to go to the AWS console. I've got an ability to configure my task definition, so I can add and remove or modify environment variables that are associated with that ECS task definition for my application. If I scroll down a little bit more, we've got really quick access into visibility into the AWS infrastructure that gets created related to my application. So as I build my AWS skills over time, this gives me a quick snapshot to understand, what are the security groups related to my application? What are the task definitions? What's the ECS service log groups that might be in CloudWatch? So we get a quick view of the AWS infrastructure resources associated with my application in this interface as well. Let me finish up a couple of the day two applications, and then I'm going to look at the Git repository and CI/CD related to this application. But I mentioned day two activities related to logs. So here's a capability for developers to simplify how they do some troubleshooting. This is direct integration with AWS CloudWatch. Now, this is a little bit boring to look at because this log message just says, "Oh, okay,
it's just working port 8080, of course, so it's fine."
Yeah. So, but typically, you would expect more logs to be here, and this built-in interface allows you to quickly search through the CloudWatch logs without having to go to the console. You can actually download them if you want to be able to have them locally and do some advanced grepping through some of those logs. But that simplification of access to things like resources like CloudWatch logs is really key here. And then we've got the capability for management. Similar to environment providers, you've got an ability to deploy the application to multiple environments. So here I can see that this one's already deployed to AML US Dev. And if I wanted to now promote this to a test or QA or a prod environment, that's built into the OPA interface. So I can come in and I can say, oh, look, I need to also deploy this to the fixed income dev environment. And I can select that environment, click add, and my application will now also be deployed to the fixed income dev environment as well. I'm going to flip over really quickly to look at the CI/CD tab. It's basically the same as what we looked at for the environment provider. I can see quick access into the GitLab pipelines. So if failures occurred in my pipeline, I've got really quick, easy visibility into that. And these links will take me directly to a pipeline if I need to do some debugging on the pipeline itself. But let's take a quick look at the application source here. So if I click on that view source, this takes me directly into the GitLab repository for this AML EMEA detection application itself. I'm going to highlight a couple of things really quickly, and then Anthony, I'm going to ask you to maybe talk a little bit about some of the pipeline stuff. But I want to highlight that as part of the repository that we've created a .iac subfolder. Now, this is just an example that we chose to use for the reference implementation. But the key thing here is that we wanted to be able to give developers the ability to build their skills over time. So the CDK source code is actually available to the developers directly within this subfolder. So they can learn over time.
Yeah.
They can modify the provisioning. They can learn over time, a little bit more about managing their own infrastructure. Some customers might choose not to put this in front of the developers. They want tighter control. That's their decision. That's their decision to make. But we, as part of our reference implementation, especially based on the feedback from that customer we were initially building the prototype for, they wanted their developers to over time build those skills. But the developers do have quick access to all of their source code, of course. And you can see here that we've got a GitLab pipeline that was automatically added along with a Docker file. But Anthony, I'll continue sharing just to simplify the experience here on Containers from the Couch. But do you want to talk a little bit about some of the pipeline specific capabilities that we've built out here?
Sure thing. Can we go back to the Backstage UI?
Yes. So here. Okay.
Maybe go to the CI/CD tab, please. Okay. So we have a couple of interesting things that we did with OPA and CI/CD. So for starters, because we said that what we're trying to do is set up these application templates that kind of come out of the box, like in a batteries included kind of mode, where it already has a default CI/CD implementation that's kind of built upon organizational best practices. That's great, but what about maintenance? So what you could do is you could say every application has their own copy of a CI/CD pipeline, and then it can totally go off in its own direction from there. Another way of doing it is to totally lock down the pipeline to say applications have no customization capability whatsoever, and they're all 100% centrally managed by a different party outside of the application developers. What we did is we kind of split the difference. So our application pipelines, they reach out to centralized solutions from a different repository. So effectively, the main crux of what you want to share across all applications, those CI/CD like component definitions are in a different repo that can be managed centrally by, say, a platform engineer. But also the pipeline does live, the definition of the pipeline does live in an app. So app developers can add their own custom steps that are specific to their app, but they basically inherit all the things that are centrally defined. It gives platform engineers a single point of maintenance to kind of upgrade versions and improve the processes and whatnot. So that's one interesting aspect. And another interesting aspect is it's kind of been implied but not directly said that we have a solution for CI/CD that can deploy across multiple environments. So we didn't explicitly call out like your typical environment names like dev, test, QA, stage, prod, but that's really what we're talking about when we're talking about environments. So our pipelines can deploy across multiple environments, and each environment can be a totally separate AWS account and a totally separate region if you want, or they can be the same account if you want as well. So what happens is our pipeline will assume a role that the role resides in the account that it's trying to deploy to, and that will give it permissions to deploy to that particular account that's tied to the environment that the developer's trying to deploy to. So we have this concept of multi-account, multi-region, and also it's dynamic. So what Jim showed, Jim, can you go to the management tab, please? What Jim showed when he showed the add environment, this is actually a pretty interesting concept, because let's say that there was only a dev environment created at the start. So developer creates their app and they deploy their app to the dev environment. Then people are happy with the app and we're wanting to create additional environments after that, like a stage and a prod, those environments can then be created by the platform developer later, and they will show up in this UI as selectable choices. And when the developer adds support for those environments, what's going to happen is that dynamically, OPA is going to modify the CI/CD pipeline to add additional stages in that pipeline to deploy to the higher environments. So it's kind of a unique multi-account, multi-region approach with a dynamic capacity to add additional environments on the fly without any coding. Back to you, Jim.
Okay, thanks.
So before we go to Jim, 1 second, we have approximately another 8 minutes. Just want to keep us conscious of time.
Okay, yeah, thank you. So I'll just highlight 2 more things because of what Anthony was just highlighting about being able to deploy to multiple environments. One other really nice thing is this drop down, this context menu up at the top allows me to choose which environment as a developer I want to look at. So right now I'm looking at AML EMEA Dev, but this application has also been deployed to a test environment. When I switch this context, the whole UI gets updated so that now when I come back into the overview here and I look at the application state, well, the application is not running right now in the test environment. When I go and look at the application logs, I don't think there will be any. Yeah, so the test, in the test environment, the application has actually not even run yet. But from a developer perspective, all I need to know is what environment I'm interested in taking a look at. I can change the context and the entire UI gets updated to reflect what's going on in that environment. The last thing that I also want to highlight is a very common day 2 activity is to be a developer, go along building, say, your microservice, and then at some point you end up identifying that as part of our architecture, I need to introduce a data store. And so I now need my application to be able to store information in an RDS database, for instance. And the concept that we introduced to support that use case is this binding of resources that you see here on the management tab. And so this bound resources card gives me, as a developer, the ability to click add. Actually, let's see, I'm not in the right environment here. Yeah, let me go back to, let's look at a different one. Commercial is at the front end, I think, Zahi. Yeah, okay. So here I'm looking at a different application that has already been bound to an RDS database. So this database it is actually very similar to applications or environment providers. It's an entity within Backstage that represents a payments DB RDS resource that's been created. And this bind interface that's built into the UI allows me to very simply add additional AWS resources that my application wants to interact with. This particular commercial banking front-end application has already been bound to an RDS database. I could bind it to an S3 bucket as well if I want to. And so I think just to wrap up, maybe the quick question is, what do you mean binding? What does that do for me?
Exactly. Does it connect, inject environment variables, automatically create a connection? What does that mean?
Yeah. So binding something like a RDS database to an application is not just as simple as environment variables. It's also network routing and permissions. And so that's what goes on behind the scenes when you bind a resource to an application is probably going to vary from one type of resource to the next. But for RDS, it's going to involve IAM permissions as well as the networking constructs that need to be in place to ensure that the application can connect to that database. For an S3 bucket, it might mean bucket policies that need to be created and updated. But all of that can be simplified for the developer.
Why don't you show them the JSON statement that got generated when this was bounded? It's in the Git, in the AWS, in the IAC.
In the IAC.
In the permissions. So these statements were essentially generated when you click bind. And because they were generated and committed, you gain 2 things. One, every access you grant to a shared resource is captured in your source of truth. So from auditing perspective, it's all logged in and everybody can see it. You can also merge this to a merge request, right? Second thing, because you make a change in the .iac, you essentially trigger the pipeline that actually going to apply that change, pick up the JSON statement, and actually grant the identity of this application access to that database you asked to be bounded. So that's the trick how we can create an environment that people can share the same resource and read and write from the same place, but still make sure it's audited, it's captured. You can put approval processes on top of it, and things like that.
Yeah. I really like this. This is very. I mean, if I had this approximately 4 years ago in my previous job, it would have made my life a lot easier. A lot easier. And we're coming on the last 4 minutes.
Yeah. I think that was it for the demo. We highlighted a lot of the capabilities. There's more behind it, but
I mean, we didn't even get into the EKS or the Gen AI parts, which I don't know if we're going to have time for that. But I will post. Of course, you're going to give the link for the site on the here on the screen. You can see, for example, it's OPA on AWS.io. You'll find all the documentation, all walkthroughs, including videos. Correct?
Yep. We have a YouTube channel.
Hold on a second. You have a YouTube channel. What do you show on your YouTube channel? So that people
there's like
11 or anything else.
Yeah. This is our website. On the bottom, there is a link to YouTube. Yeah, all the way on the footer.
Oh, yeah.
YouTube video. Yeah.
Okay. And it's also here on screen and in the chat as well, so you can go over there. So I assume these are all the walkthroughs and explanations and examples of how to do this.
Yep.
I have a quick question for you, but I don't think you're going to be able to answer this question because we only have 2 minutes before I think. Thank you for all your time today. What is the most bizarre thing you've seen a customer build with this?
Well, the requirements, I'd say, between customers are very different. What you think might be that's the way to do things, it may not be the way to do things for some customers, but I think that's exactly where the power of something like OPA is, because nothing is set in stone. You can say, I'm not using these tools, I need another tool. And because you're using Backstage, a lot of those plugins already exist for those tools. So the amount of effort for you to build something like this can drop significantly to a matter of a few months rather than years to build a platform. I think that's the real power of why we built this.
I like that answer. I want to thank all three of you, both Jim, Zahi, and Anthony, for joining us today. It was extremely informative. Something I learned, of course, when I'm on this show, I learn something every single time, something new, but I definitely learned a lot of new things today. I want to thank our viewers, of course, who were with us as well, people that were in the chat, Sandeep Gupta and Electric Universe, and of course, Eitav and Dov, and who else am I meeting over here? Shreyas. Thank you very much for participating. I hope you enjoyed the show. Don't forget to hit the subscribe button for the Twitch channel, also the YouTube channel, and that notification button so that you can get a notification for the next episode. Next week, we're going to be back with another Containers from the Couch, an EKS episode. I think the week after that, we're going to be on a bit of a break. But an event, Thursdays, 12 p.m. Pacific time. Join us here again for another Containers from the Couch. And again, thank you, gentlemen, for all the amazing knowledge you shared with us today.
Thank you, Maish. Thank you.
Thank you very much.
Have a good day.